Hello everyone, and welcome to the first chapter of the Hacking Course 101, Linux. If you haven't yet, I'd love if you could check out our Discord server down below in the description. Its purpose is to share knowledge and resources about computer security. We have an amazing community of people from all skill levels, beginner, intermediate, advanced, even professional. It's an amazing opportunity to engage with hackers within your skill level and study or work alongside them, or even ask questions to those above your level. Without further ado, let's begin. Today's topic is Linux. What is Linux? Linux is an open source operating system. It was created in the 90s and it's still present everywhere, from your phones to your cars to your refrigerators to supercomputers, even in the stock exchange. It's one of the most reliable and secure operating systems in existence. It's incredibly customizable, as we will see later on. It's not controlled by a single company. Since it's open source, everyone is allowed to contribute to it. What is inside an operating system? An OS, which is short for operating system, is composed of several different pieces. The bootloader, which is responsible for the boot process, which we will see later on as well. The kernel, which is the piece that people actually call Linux. It's the core of the system. It manages everything from CPU to memory and peripheral devices. It's the lowest level of the OS. Daemons. Daemons are simply programs or services that run in the background. The shell. I like to call this the key to the Linux soul. It's basically the terminal. It's the command prompt of Linux, if you will. The X server. This is responsible for the graphics server. The desktop environment. This helps the user interact with the OS. We will see later on how it works. Applications. These are just the normal applications. Why use Linux? Well, freedom. Linux is the embodiment. You see, when you're using Windows or Mac OS, you are not allowed to change the core components of that operating system at the lowest levels. With Linux, you can. You can make your Linux operating system become whatever you want. And that is why there are so many different Linux flavors. And with this freedom comes a lot of privacy as well. As we're going to find out throughout this course, Windows, for example, logs every single thing that you do in more than 12 different ways. Furthermore, it periodically sends information to Microsoft. Linux doesn't do that. In fact, most Linux distributions don't send any data at all, and all logging procedures are very well documented. Stability. Linux is the most stable operating system in existence. In fact, its uptime is 99.9%. Security. As we're going to see later on, Linux is incredibly secure due to the way that permissions are set up. Convenience. Linux is very, very convenient. For Windows, for example, if you have an update, you need to restart your computer, usually. In Linux, you don't have to. You can install your updates whenever you want, and when you do, you don't need to reboot most of the time. Efficiency. Linux is incredibly efficient, which brings me to the next point, which is flexibility as well. The efficiency of Linux allows it to run fast in older hardware, which Windows cannot do. Finally, it's free. It's very, very free. Not only free, but open source. So you don't have to pay hundreds of dollars for a valid license. Linux file systems. Let's look a little bit into the layout of the Linux. Here we have a little table that compares Windows and Linux. And for Windows, as a partition, it's called disk 1, while for Linux, it's the dev sda1. We will see all of this in a moment in a virtual machine. The file system type for Windows is usually NTFS or VFAT, while for Linux it depends and can be either of the conventional ones. Mounting parameters for Windows is usually the drive letter, while Linux is mount point, and the base folder where the OS is stored is usually the C directory, while Linux is the / or the root directory. This is the layout of the file system. We have a base directory, which is called the root directory, which would be the C directory in Windows. Here we can see that we have many different directories, such as mnt, media, lib, home, etc, dev, boot, and usr, user, as well as opt, bin, sbin, etc. We're going to look into some of these later on, but it should give you an idea of how the file system works. If you want to read more about file systems, there is a resource that I put in the Google Drive down below in the description. Let's talk a little bit about the boot process in Linux. What happens when you press the power on? Well, when the computer is turned on, the basic input-output system, also called BIOS, initializes the hardware, which includes screen, keyboard, etc., and also tests the main memory. This process is also called POST, Power On Self-Test. The BIOS software is actually stored on a ROM chip on the motherboard. More on that later. After this process, the BIOS passes control over to the operating system to handle the rest of the boot. The next step is the bootloader. And the bootloader is separated into two different stages. There is the first stage. For systems using the BIOS MBR method, the bootloader resides at the first sector of the hard disk, also known as the master boot record. Its size is 512 bytes. This will be actually pretty important when we discuss specific kinds of malware. In this stage, the bootloader examines the partition table and finds a bootable partition. Once it finds a bootable partition, it then searches for the second stage bootloader, which could be grub, ISO Linux, etc., and loads it into RAM, random access memory. For systems using the EFI UEFI method, it's a little bit different, but it's the same purpose, to launch the second stage bootloader. The second stage bootloader resides under the directory /boot. It is responsible for the splash screen that you experience, telling you to choose an option. After choosing that option, the bootloader loads the kernel of the selected operating system into RAM and passes control over it. Now, this second stage bootloader is also responsible for loading the initial RAM disk, which we'll be talking about right now. The initial RAM disk, or init RAM-fs, contains programs and binary files that perform all actions needed to mount the proper file system. It provides the kernel functionality for the needed file system and device drivers for mass storage controllers with a facility called udev, which we will actually see if we boot up a Linux operating system. The mount program instructs the operating system that a file system is ready for use and associates it with a particular point in the overall hierarchy of the file system, which is the mount point. If this is successful, the init RAM-f is cleared from RAM, and then the init program on the root file system is executed. The init program is this sbin init. Oops. I apologize. Anyway, the init program is this sbin init. It handles the mounting and pivoting over the final real root file system. If any special hardware drivers are needed before the mass storage can be accessed, they must be inside the init RAM-fs image. Let's talk a little bit about the Linux kernel still. The bootloader loads both the kernel and the init RAM-fs into memory, as we've seen before, so it can be used directly by the kernel. When the kernel is loaded in RAM, it immediately initializes and configures the computer's memory and all of the hardware attached to it, which includes processors, I/O subsystems, storage devices, etc. The kernel is also responsible for loading some necessary user space applications. Now, when control is passed to the sbin init, so when init is executed, it becomes the initial process, which in turn starts all other processes to get the system running. Most other processes on the system trace their origin ultimately to init. The exceptions are obviously kernel processes, which are started by the kernel directly. Besides starting the system, init is also responsible for keeping the system running and for shutting it down cleanly. Whenever necessary, one of its responsibilities is also to act as the manager for all non-kernel processes. It cleans them up after completion. It basically acts as a janitor. Which operating system should you choose? This flowchart here is very important. You'll find this image also in the resources down below the description inside the Google Drive. Let's learn how to install Linux. As I said before, I recommend Ubuntu, OpenSUSE, and Fedora for beginners. However, for computer security, I believe Kali Linux is an appropriate operating system for beginners as well. So I will be making all my demonstrations with it. To install it, just go over here and search for Kali Linux. Kali.org is the website that comes up. Click Downloads, download Kali Linux. Now you can download the image itself, or you can download an image specifically for VirtualBox, which is the virtualization software we're going to be using. Let's download it as the OVA for 64-bit. Downloading. Now let's download VirtualBox as well. VirtualBox is a virtualization software. It allows you to run images of entire operating systems from this program. So you don't need to install a brand new operating system into your computer. You can run it from a virtual machine. You can run as many instances as you'd like. I'll go through all of the configuration with you in a moment. So we're going to click on Windows Host because I am in Windows. I'm going to pause the video and come back when all of these are complete. The files have finished downloading. Let's open up VirtualBox first. It is installing. Next, next, next. Proceed with the installation. Install. It is installed. Start Oracle. I had to switch computers, but don't worry, every step should be exactly the same. Now I'm in Oracle VM VirtualBox. You should see all of this blank. Please ignore these three groups here. The only thing you have to do is go to File, Import Appliance, click on the folder, and then search for the file you just downloaded. In my case, it's right here. Then you click Next, then reinitialize MAC address. It's a good practice. Then import. Now this might take a minute or two or even an hour depending on your system. This will import the entire operating system into the program. Here it is. Now if you right click and go to settings, you can adjust a such as the RAM. If you go to system, you can adjust the base memory. I do not recommend going above 2 gigabytes. It doesn't hurt, but you shouldn't need to. 1 gigabyte is more than enough. I like to put it at 2. You can change the number of processors, and you can change acceleration. You can also change the video memory. You can also change the network type, and we will see this in further detail when we do different kinds of attacks. But there are many different network configurations that you can choose from. NAT and bridged are the most common ones, although internal network will be very common for us too. For now, just leave it at NAT. 0 ports, USB, and shared folders. Shared folders are also very important. What is a shared folder? Well, it's basically a folder that you can access both on your current machine, on your host machine, and in your Linux machine. Let's add one as an example. The folder path can be pictures, shared. Select folder, auto mount, and the folder name is now shared. Now let's start the system up, shall we? The system has booted. The default password, the default username is root, and the default password is TOOR, which is root backwards. Now we're entering the operating system. If you resize the window, the whole system would adapt to it. The first thing that you need to do as soon as you land yourself right here, after you just installed your operating system, is open up a terminal right here. This is the terminal. And we're going to update the system. The first thing you should do is the command apt space update. Oh, there is an error. And this occurred to me because I haven't updated it in such a long time. This error, the only thing you have to do is type gpg --key server hkp, and don't worry if you don't understand any of this. We will cover it later. Keys GNUPG.net receive key, and it's set D8D0B F7 F6. There we go. It's important. It's imported. GPG fingerprint. Ooh. There we go. So now if you put apt update, oh, I completely forgot to do the, my bad. There we go. Now apt update should work. There we go. It's updating the repositories. There we go. Now apt upgrade, or actually apt dist upgrade, to upgrade everything in the system. And now this is going to be 2 gigabytes of archives. I would normally click yes, but for the sake of this video, I will not. And you're done. This is your new operating system. It's Linux. Let's talk about Linux commands. This is a very basic list of commands that I think every beginner should know. There are many, many more. I will not go through all of these. I will only go through the most important ones. The first command we're going to talk about is the ls command. It lists the directory. If we do ls right now, it will list all the current files and directories within the directory that I am in right now. How do I know which directory I'm in right now? Well, I can look at this part right here, which tells me that I am in the root file system, or I can do the command pwb, which prints the current directory, which is -root. So it's the root partition. Now, to change directories, let's say we want to go into our desktop. We use the command change directory, cd for short, cd desktop. And now I'm inside desktop. If you want to go back, you can type cd space 2 dots, and it goes back one directory. This command it creates files really fast. This is very, very useful. Let's say file3.py. Nothing seems to happen, but if I type ls, we see that we have this file here now. A very important command is the command add user. The command add user adds a user to your operating system. Now, I didn't put the command correctly. The correct command is add user and then the name of the user, let's say darkarp. Now it asks for a password. Let's type a random password again. And I would ask for the full name. This is completely optional. You don't need to press any of that. Then, is this information correct? Yes. Boom. Now another user exists on the system. And we can see that because we can do something like su and then darkarp. This su command basically puts you inside another user account. In very basic terms, we will discuss all of this later on, so don't worry. Now if I type who am I, again another amazing command to see who you are in a specific system in terms of what kind of privileges you have, etc. Who am I is very useful. The clear command is also very useful. You can also press Ctrl L to have the same effect. Now, let's say that we want to create a file called secret. The command nano is very important, by the way, because it allows you to edit files and create files as well. This is a secret. I am typing directly into the file called secret. To save, I can type Ctrl X and then Y to save and enter. Oops, permission is denied. The reason permission is denied, I'm going to Ctrl X and say no so that we don't save, is because look at our directory. If we press pwd, I'm inside a root directory, but look at my username. Who am I, right? I am darkarp, and this does not have administrator privileges. So I need to go back into my root system and do the exact same command, nano secret. This is a secret. Now again, to save, Ctrl X, Y, enter. And now, if you type ls, you will see secret right here. Now, how do you read the contents of that? Of course, you can always do nano, but this is a text editor. There is another way to read the contents of files, and that is called the cat command. Cat, the name of the file, in this case, secret. Also, if you press tab in the middle of writing a word, it will try to complete for you automatically. For example, I will press tab now. It auto-completed. See? There we go. This is a secret. Now let's add another line. This is another secret. And then I'm going to cat secret. Both lines appear. Now there's another command which is basically cat but the other way around, so tac, which which reads the file and outputs it, but in the reverse order. So the last lines are printed first, as you can see right here. Not the most useful thing in the world. Now, there is another command which is also incredibly useful, and that is the ps command. The ps command will show you all of the running processes. Well, ps-help, ps-all should list all single processes that are running in the system, but this is way too big for us, right? This is way too big of a list. So how do we make it more manageable? There's a command called less. This command, let's say that we have a file. Well, we do have a file named secret. This outputs the file, but it outputs the file in a pretty way so that the contents are visible to you. The entire contents are visible to you. And you can switch multiple pages with page up and page down. Now, how do we use it alongside the output of another command? Now, we could use the redirection route option. We can do something like ps-all to list all the processes, right? But instead of just pressing enter, we could type this greater than sign and then say ps.txt. Now, if you type ls, this ps.txt was formed, and if you cat it, it contains all of the output of that program. So what happened? When we did that, ps-all run that command that showed all of this. And then instead of showing it to us, we told them to output it into ps.txt file. Now what we can do is we can say less ps.txt. And this is how it works. This is the start of the program. And as soon as it hit end, you can type page down and it will continue right from where you left. And you can continue to go page down until there is no more, and it will warn you. To exit, you can press Q. Of course, there's also the command H, so you can see help. There's another way of doing this called pipes. Now, a pipe is when you redirect the output of one command to another one. For example, this, instead of redirecting the PS to the file, I could redirect it directly into the less command. And this is what the pipe is. This is a symbol of to say pipe this into that. So it gets the output of the first command and then it feeds as input to the less command. And you see that the results are exactly the same. Now, there are many, many, many other commands. And I would love if you could look at all of them. And we will cover a lot more of them later on when we talk about how to get more comfortable with Linux. For now, I will leave you with this and one little tip. If you want to type commands that you've previously typed before and don't want to just type the whole thing again, you can press the up arrow and you will see the commands that were typed before. Up and then down, up, down. If you want to check the entire history, you can type history, which is another command, and it will show you the entire history of your commands. And of course, you can always use our newly learned pipes and less to make it all pretty and fit in the screen. Before we finish this part, there is one command that I would love to show you. And this is the most important command of all. It's called the man command. I use it a lot Many people everyone uses it a lot, even people with a lot of experience. This command is used to get information about a specific command. For example, the ls command that we've seen before. If you aren't sure of how to use it, for example, you can type man, which is short for manual, space the name of the command, in this case ls, enter. And this is showing every piece of information. To navigate, you can press page down and page up. It's giving all the different kinds of options that you can have. So for example, if I put the -a option, it says do not ignore entries starting with dot. Let's try that out. So let's press Q, ls-a. Oops, ls-a. Oh, there we go, see? Directory.nano.rnd, it's showing directories that start with a dot. These are usually hidden directories in Linux. There is another command that has a similar function to man called info ls. Oh, apparently info does not exist. Oops, I messed up. Amazing, info doesn't exist by default. This is really, really interesting. I had no idea that on Kali Linux, well, I thought that on Kali Linux it would be there by default. I never really use it. They tried to make it a thing, but it never became a thing. It was meant as more, I'm going to do it again just so you can see. So info, then the name of the command, used in exact same way as the man. They wanted it to make this into a more in-depth tutorial on a command rather than just showing options, but it never really gained any momentum. But it's still noteworthy. You can still go page up, page down, and then you have hyperlinks, which you can access by pressing enter, and then you get really lost in here. In either of these environments, either in man or in info, you can type capital H, so Shift H, to see all of the possible keys and combinations so you can navigate successfully. See again some of the most important commands. So man info, as if there's also the sudo command, which is used as sudo space a command, and it makes it execute as root, so as administrator. Root is basically the administrator of Linux. Then apt update updates the repositories, does not update anything in your system, only updates the repositories. We're going to understand a little bit more of that later. And then apt upgrade actually upgrades your packages, your programs. Then apt disk upgrade upgrades the entire system fully. Now this capital A on apt should be a lowercase. I apologize. Linux is case sensitive in directories, file names, anything. So have that in mind. Now where do you go from here? Linux is a notion of different flavors. This made no sense at all. I'm incredibly tired. Basically, you go any direction you want. I encourage you to try one of the operating systems that I talked about, specifically Kali Linux, because it's the one that I'm going to be using on most of my demonstrations, if not all of them. And just play around with it. Play around with the terminal, play around with configurations, etc. And definitely check out the resources that I have put up on the Google Drive down below in the description. This terminates the first chapter, Linux. Thank you very much for watching. I hope you've enjoyed it, and stay tuned for the next one.